All right, let's get right into it. Have you ever looked at an exam question and wondered what on earth the examiner actually wants to see? Well, today we are pulling back that curtain. We're going to take a real GCSE physics question and break it down, piece by piece, using the official mark scheme. I'm going to show you exactly how to get every single mark. So picture this. What if the pavement you walk on could generate electricity with every single step? It sounds like something straight out of a sci-fi movie, right? But it's a real-world concept, and it's the whole idea behind the exam question we're about to tackle. This shows that it's not just about some abstract formulas. This is the physics that could literally power our future. So here's our plan for this explainer. We'll kick things off with the pavement power challenge. Then we'll dive into each part of the question. First, the power equation, then calculating the current. After that, we'll switch gears to the efficiency equation and figure out the useful power. And to finish, we'll wrap it all up with the absolute key to grabbing those full marks every time. Okay, let's get to it. This is question 03, and it's taken straight from a real paper, the AQA GCSE Physics higher tier paper from June 2022. Yep, this is the real deal. So this is the exact scenario the exam paper lays out for us. You see, it sets a really clear, practical scene. We're not just solving for X, we're figuring out the physics behind a specific, cool piece of technology. First up, question 03.1. Now, this is a classic one-marker. It's designed to be a quick check. Do you know your fundamental equations? The goal here is super simple. Just pick the right formula. The question asks for the equation that links current, potential difference, and power, and you're given 4 options. The key here isn't just knowing the right answer, it's about spotting it among the others, which, you'll notice, look very similar. They're designed to trip you up if you're not 100% sure. And boom, there it is. The correct choice is P equals V times I. For this question, the mark scheme is looking for one thing and one thing only. Ticking that box gets you the mark. Simple as that. That's our first point in the bag. Easy. Right, so for question 03.2, we have to actually put that equation to work. This is a calculation question, and it's worth 3 marks. Now that's a huge clue. It tells us that showing our working is going to be absolutely essential. Okay, so the problem tells us that when someone steps on a tile, we get a potential difference of 40 volts and a power output of 4.4 watts. Our job is to calculate the current. All the numbers we need are right there. We just have to pop them into our formula correctly. Now this is so important. How do we get all 3 marks? Well, here's the secret right from the mark scheme. The first mark is just for substituting the numbers correctly into the equation, 4.4 equals 40 times I. The second mark, that's for rearranging the formula correctly to find I, so I equals 4.4 divided by 40. And that final third mark is for the answer itself, 0.11 amps. See, the process is just as important as the final number. Okay, we're halfway there. Now the question changes focus a little bit. We're moving away from power and current and onto a new concept, efficiency. And just like before, we're going to start with the basic formula. So next up is question 03.3. And you'll see a pattern here. It's another 1-mark multiple choice question. It's another quick knowledge check before we get into the next calculation. The question is simple. Which equation correctly defines efficiency? And there's our answer, exactly as the mark scheme wants to see it. Efficiency equals useful power output divided by total power input. You tick that box, you get another mark. Just remember, it's always the useful stuff out divided by the total stuff in. And now for the final calculation, question 03.4. We're going to take that efficiency formula we just identified and apply it to the LED lights being powered by our clever pavement tiles. So here are the facts. The LED has a total power input of 4.0 watts, and its efficiency is 0.85. And notice, efficiency doesn't have any units, because it's a ratio. Our job is to work out the useful power output. You know the drill by now, right? Let's break down that 3-mark structure again, straight from the mark scheme. You get 1 mark for the correct substitution, 0.85 equals P divided by 4.0. You get another mark for the rearrangement to find P, so P equals 0.85 times 4.0, and that final mark is for the correct answer, 3.4 watts. By showing these 3 stages, you guarantee you get the points, even if you mess up the final sum on your calculator. So we've broken down all 8 marks in this one question. But what's the big picture here? What's the secret key that unlocks full marks in pretty much any calculation question you're ever going to face? It all comes down to this four-step process. First, always write down the base formula you're using. Second, clearly show you substituting the numbers in. Third, show your rearrangement of that formula. And finally, number 4, present your final answer with the correct units. This four-step method is like a safety net. It tells the examiner you know exactly what you're doing, and it helps you secure marks every step of the way. And that's our deep dive into the mind of an examiner. So I'll leave you with this question to think about. How many marks in your next exam could you secure, not by knowing more physics, but just by making your thought process clear on the page? I bet it's more than you think.